So how we doing? Notice the directions they want me to graph. And they also want me to find the domain. So, this is an interesting function. It's not like a single function. It's like broken into pieces, right? And that's why we call these piecewise functions. Because it's not just something like x plus 1. It is broken into two separate pieces in this case. Sometimes they're broken into 3 pieces or more, so just FYI. But regardless, this is what they call a piecewise function. So, let's make certain we understand something. They tell me that the function is equal to 2x if x doesn't equal 0. Well, if I create a table, that means x could be what? It could be 2, it could be 1, can't be 0, it could be -1, it could be -2, right? Okay. And the function is equal to 1 if x is equal to 0. Well, that means the only thing on this table is x being 0. Are you with me? Okay, so let's do some plotting. We have x being 2 on this first piece, and y is going to be 4. If x is 1, y is 2. If x is -1, this is -2. If it's -2, it's -4. Got it. Got a question. If x was equal to 0 here, y would be equal to 0, right? Okay. There's a reason I'm putting that there. Hold that thought. I promise there'll be a good reason why it's there. Okay, here if x is 0, well, according to this function, y is going to be 1. All right, so let's take a look at our graph over here. Let's start plotting our points and see what's going on. We have the point 2, 4, so 2 and 4. We have the point 1 and 2. We have the point -1, -2, and we have the point -2 and -4. Now, here's what I want you to notice. If you connect these dots, do you notice it's going to pass through the 0, 0? So, I'm allowed to connect the dots, but as soon as the line tries to pass through 0, 0, it creates this open circle, which means, hey, you can't use this point on this part of the graph. So when I connect my dots, and I'm going to make sure these points line up as best as possible, this is what the graph of the first piece looks like. This is where f of x is equal to 2x, but it can't be equal to 0. So we have an open circle there saying, can't use this point. Good? Okay. And the reason we can't use that point is because the second piece said, if x is 0, then y is 1. So if x is 0, y is 1. This point kind of got moved and picked up to this point 0, 1. Good? Okay. So it's an interesting graph. And no, their pieces are not going to connect, so don't try to make them connect. It's okay if they don't. That's the way it goes. Good? All right. Now, let's look at the domain of this function. Domain are my x's, right? Okay. Now, I'm going to choose to look over here for a moment. This first piece says I can use every x I want but 0. But the second piece says this is where you can use 0. So let me ask you something. Are all the x's being used from -infinity to +infinity? Because this one says use any x you want but the 0, but this one allows you to actually put the 0 back in. So is this my domain? Some of you say yes, some of you are uncertain. Look at the graph. I'm looking for the domain. What x values is this graph using? So this keeps going down, I get it, but it keeps going to the left. which means will it eventually hit negative infinity? It will. This part of the graph will use negative infinity up until the 0, but this graph can't use the 0. That's okay, because this portion of the graph does use the 0 for x. And then when I continue past the 0 to the right of 0, again, I'm going to end up all the way to positive infinity for the x's, because eventually this thing will go that way. So is this the domain? It certainly is. The domain is definitely negative infinity to positive infinity. Good? Okay. Let's do a bonus. What do you think about the range? If we come in from the bottom at negative infinity, is negative infinity for the y's being used? Yeah, because this thing keeps going down. So the range will definitely start at negative infinity. We're moving up, moving up, moving up, moving up. So far, so good. And then I hit here. And this is where y equals 0. But that's a hole. And I'm not seeing the y being equal to 0 anywhere else. So on my range, I kind of have to stop at that 0, don't I? Because I can't use it, can I? But if I notice, after this, it picks up and it keeps going up to positive infinity. And this is y being 1, and it's also on here. So my range happens to be in a couple of pieces. By the way, remember, this u means or. So the y values are in this interval or they're in this interval. That's what the range would be for this particular function. Good? Does it make sense? Okay, so I have a couple of examples coming your way. Work on them before you find my answer key video. Catch you on the flip side.